My name's Ian Eyberg. I'm CEO over at Nano VMs. We work with Unikernels. So this talk's not really gonna be like an intro. We'll briefly kind of go over what these things really are, but what I really wanted to talk about was how users are actually using them in prod for the past couple of years, because we've had users and customers in prod for 3 or 4 years now, and so there's lots of different like patterns and different ways of using these things that have kind of emerged based upon that usage. But yeah, just to kind of get into it, to describe to those in the audience that have never heard of these things, what exactly is a unikernel? Essentially, in the public cloud, or in the data centers of old with vSphere, we would have virtual machines that would take an operating system and virtualize it, and then you would kind of run your apps on it, right? Then we had the Docker stack and Kubernetes kind of come in, and they kind of split that up a little bit more by adding more layers. Unikernels kind of went the exact opposite direction. Instead of adding layers, they removed them, because they took this realization that when you're in the cloud, you already have that underlying operating system. If I go to Google or Amazon, they already have one Linux there. You don't need 2 layers of Linux. And so there's a lot of optimization and things that you can do when you realize that. To get into how we even got to this situation to begin with, though, we have to go back in time. In fact, we have to go back 50 years ago. So on this picture on the left, we got Ken Thompson, Dennis Ritchie. They're co-creating Unix on a PDP-7, PDP-11 here. So just look at that computer. It takes up the entire damn wall. It costs like tens of thousands of dollars when it came out. It was quite the beast. But that's the computers of that time period. And that's what they had to work with. And so, when you're thinking about Unix and how it works with this notion of many users and many different applications, this is why that exists, because of those computers back then. It's not because of the computers that we have today. So you fast forward about 20 years into the future, and you got this not small, you got this college student. And, this was an interesting time period, because we had what's called the Unix wars. And we had all these different companies trying to sue each other over the rights to use various proprietary versions of Unix. And he's like, you know what? Well, why don't we just have a free one? And so obviously, Linux was born, and that just kind of like really changed everything at that time, because for the first time, we really had access to, this free server environment, which is interesting because it wasn't really made for that purpose back then. But this was also an interesting time period, because we had our first browsers like Mosaic. We also had, the first .com wave and so forth. So this is a really, really special time period. And then, 10 years later, we have Diane Green and her husband, Dr. Rosenblum. And, when I think, VMware first came out, a lot of people thought it was total shit, and for good reasons, right? But it got really good really fast. And, that was kind of like the second big wave of what happened, was when they were able to just sit there and virtualize entire operating systems. And it was really important, because it set the stage for that small bookstore in Seattle called Amazon to create what we now call the public cloud. There's another 5 years later. And so this evolution that went on, and this time frame, it's about 30 years, right? This entire evolution created, for the first time, the ability to completely unshackle the chains of hardware that developers were, holding on to. And so for the first time, we could actually design systems that didn't really need to deal with underlying hardware. So if you look at like every file system ever created, it's all optimized to deal with hard drives crashing, basically. Well, you're in the cloud, you don't really worry about that. The people who run the cloud do, but you as the end user don't need to worry about that. Certainly not in the virtual sense. So that's where unikernels start to come in, is when you start thinking about these things and you start thinking that we can kind of change things differently. So, I come from the security world. That's what kind of attracted me to this space. We didn't invent this. We kind of stole it from academia and just started commercializing it. You'll see this like, oh, it's got a tenth of an attack surface. To me, from a security perspective, I don't really care about that because it's irrelevant for me trying to break into your server. Uh, as somebody who wants to break into your server, it's like breaking into a house. You know, you might come through the door, you might come through the window, but that's not why you're at the house. You're at the house to take the guns and the jewels and the money and flat screen TVs and all that stuff. It's the same thing from an attacker's perspective when they're breaking into a server. You know, they exploit that you know uh, remote process open in the JVM just to install a crypto miner or to spawn MySQL dump or some other nefarious activity. And so that's kind of like where unikernels come in because they really only focus on running one and only one application. They quite literally can't run other applications. So sure, you can start pulling out all your ROP gadgets and go create like a MySQL dump out of pure ROP. But I've actually never seen that before. I only see a fork exec to a shell, then run MySQL dump. So that's kind of the level of, you know, capability we want to bring. You know, just to compare against something like a Docker or something, you know, Docker still has shells, still runs Linux, still has a notion of users. Like unikernels literally don't have users. I'm going to show you a demo real quick here. Lines of code, obviously. Performance is interesting. You know, when you run under something like Kubernetes, especially in a hosted environment, your performance actually goes quite down really fast, mainly because of the usage of underlay and overlay networks. But the same thing is happening at the storage level. Whereas when we deploy to Amazon or Google, we have raw access to that disk. We have raw access to the NIC. So not only do we have all the less overhead from something like Kate's, but we're actually running a lot faster than Linux. You know, 200% faster on Google, sometimes up to 300% faster on Amazon. It depends from driver to driver, hypervisor to hypervisor, but in general, that's kind of like what we see. So yeah, let's just jump into a demo so you guys can kind of see what exactly we're actually even talking about here. Let's see if might be hard to kind of see this in the back, so hopefully I bump that up enough. So if you know Go, this is your basic Go web server, right? Just listens on you know, port 8080, says hello. What we can do is I've already compiled this. You can see that this is for x86, 64-bit. I'm on an ARM machine. Doesn't really matter. We run x86, we run ARM, we even do RISC-64. We prepared that when we didn't even have hardware for it. But this is x86 because I'm going to go ahead and deploy it to Google in a second. But to kind of show you how this works, you know, it's very similar to many other systems that you might be using. Here, I'm passing in the AMD 64 flag just to kind of tell it, hey, I want it to run there. And you can see that it's up and running already, right? So, you know, we can kind of hit that up. It says, welcome to my website. Okay. So the next step, and this is what I always tell people, is it's one thing to run it on your laptop, but you're not going to get the aha moment until you actually deploy this to like Google or Amazon or something like that. So we can go ahead and do that real quick. I'm basically just passing a bunch of things here. See if I can get some of this a little bit readable. So West 2. Let's see what else. Yeah. Oh, here we go. Okay. So if I can ever learn to type, essentially what we're doing is create an image. When you create an image locally, what it's doing is it's taking that raw ELF binary and then throwing it into a disk image. As this actually creates, I can kind of show you real quick what that actually looks like. So this created a disk image of like 20 meg in size. And you know what? I think I just screwed this up. But let's just go ahead and tell it the right architecture. But yeah, so this was like 20 megs, and and you can kind of see what it is. So obviously, it's a raw disk image that we're uploading here. So this is everything the system actually needs to boot and run and everything. There's no like external orchestrator. There's no external anything that you need. That's what the cloud gives us. So you upload it, and you can show the so these are some of the instances that we already have running over here, and you can see that the image was created. So go ahead and just spin it up. So an instance create. Think give it like a 8080. So once the image is done, the instant spin up is pretty fast. And so it's up. I'm gonna go ahead and refresh this. So we have our instance here, and we can kind of go ahead and curl it up. Might have messed that one up. Tell you what, I'll spin up a couple of these guys just to see if I get it correct. Well, Dimmu God's not favoring me this time. But anyways, so it's pretty easy to spin these up. And as you can see, it just kind of is instant. Could switch back to this. So, I mentioned there's kind of the overview of what these are, but how people have actually been using them lately. Monitoring is actually one that's it's pretty big. So we have this concept of a Caleb, and they're basically just different kernel libraries that we can link into these individual applications. And so native integration to like things like CloudWatch and DigitalOcean's metrics and Azure's metrics and so forth. There's things like GCP logging and so forth. You have we even have like a WireGuard support. So if you could have a WireGuard network, you can just kind of link straight in. And then there's other interesting things that are like very unikernel specific. So we ported Google's user mode threading, user mode concurrency groups over. Basically, what it allows you to do is have control over when to switch to different threads. So that's something that pairs very well with these things. Which clouds, which hypervisors, all of them we support. So it's literally everything you can mention. Languages, we have a variable Rosetta Stone of language support with full examples. There's really nothing that you can think of that we can't run, and we purposely designed it for that. I mentioned monitoring a while back ago. There's all the hoopla about you can't debug unikernels and so forth. I think we've kind of proven that wrong quite a bit. Not only on kind of the APM side, but also just the vast amount of debugging and so forth that we actually have to do just to work on stuff. So this is a big one in the past year or two. We ported NVIDIA's GPU driver over, and so we have like more than a handful of blockchain customers, and I don't really know too much about that space, but I do know that they really like Unikernels and they make heavy use of GPUs. So that's something that has been being used quite a lot lately. There's other things that we've done like porting OBSD's pledge and unveil over. Again, not being Linux, that gives us lots of freedom to do all sorts of interesting things like this. So we can provide, different security guarantees that, Linux simply can't. And I mentioned the UMCG. So happy to jump into questions from here, or if got other demo things.
I just have one quick question. So unikernels are not Linux. So does that mean that, like, what is a unikernel written with? Like,
yeah, so good question. Essentially, we wrote a kernel from scratch called Nanos. And so it's got a Linux compatibility-ish, but there's a ton of stuff that it doesn't have. So when I was talking about Ken Thompson and Dennis Ritchie on their PDP-7, for instance, unikernels straight up don't have users. You can't log into them. You can't SSH or spawn a shell or anything. Why? Because it's only running one program. So it'd be like asking, can I SSH into that Go web server? It just doesn't even really make sense. And when we get rid of that construct, we get rid of this kind of notion of like all these users. I mean, like half this audience doesn't even use the users on Linux today. They just sudo up and then screw it. So that concept is kind of gone out the window. And what we do is by getting rid of that construct, we can solve a ton of security issues, at the same time. But yeah, just to kind of show you real quick, this is what the actual file system looks like for that image that I just made, that Go web server. This is everything on that file system. Now you'll see proc there, but that's like fake. It's there only because Go and some other languages do expect certain stubs. So in certain cases we'll put in stubs for that. I also said no users, right? Well, you see this Etsy password. Again, that's a stub that's there only to facilitate calls to, get UID or whatever, because programs will expect something. But what's funny is that they never really look at the result of it. So it's pretty easy to get around a lot of those issues. And then, you got your certs and like libnss, things like that. So now if you look at like something like Python or like a Java, you're going to see like 1,000 files on there. That's not something that we really, try to deal with. That's kind of application specific. So,
I know you mentioned that debugging is still something that you guys have tackled, but I am curious. Like, I think sometimes it is useful, at least in the existing stacks I've worked on, to like shell into some production web server to debug stuff. Like, what's the workflow like with unikernels?
Yeah, so we say instrument whatever you think you should have instrumented. And so like to start off with, people will start with like logging, for instance. By default, these things will output stuff to serial, but serial is super slow, so it's not something we recommend for prod usage. In that case, people have their Splunk or Elasticsearch or whatever it is. And so you start with that. And then you'll probably go to APM next. So, there's 1,000 different APM integrations, whether it's memory or disk or GC or, whatever it is, start instrumenting that. And then in other cases, debugging can actually get even easier. So especially on something like Google Cloud, you can export a running virtual machine as a disk image. You can download it and attach to it locally. And you can get like really crazy, and we can use GDB and everything else, and we do use it from time to time. So yeah, I mean, there's options, and it's just different workflows usually.
So I feel like I've been hearing about unikernels for a number of years now, but I haven't seen a ton of adoption. Why do you think there hasn't been more uptake in general in the industry?
Yeah, so there's been like a variety of projects, and some of them come and go. Half of them were coming from academia, and so those really, those really never had a chance to go anywhere. But going back to what I was talking about earlier, Linux being 30 years old, at the end of the day, a lot of people kind of underestimate the amount of work that goes into creating what is actually an operating system. It's just a special type of one. And so I think these projects will spring up, and then there's just not enough resources thrown at them to take them anywhere. We were lucky enough to kind of dance around that because we were able to get customers and other ways to kind of pay for the continued development of it. So.
Hi, I have two questions. What's the state of interoperability? So can I run nanokernel in Fargate and EKS? So
it's a common question. Yes, you can run it under Kates, like using something like KubeVirt. I wouldn't. If you're going to run it under Kates, then you definitely want to use that. Otherwise, you're going to take a massive performance hit because these things are provisioned as virtual machines and not containers. And generally speaking, though, we only recommend that if your org is like super heavily involved in it. If not, then we say just deploy into a VPC or whatever and go from there.
So now there's going to be a separate reverse question. Can I sidecar a kernel that's doing something like instrumentation and health checking and stuff like that, and basically sidecar it to a main app kernel?
So sidecar is no, but what you can do is you can have the exact same behavior using this mechanism that we call a klib. And essentially, that's how we attach kind of third-party code in a language agnostic way. So, any of the 100 different integrations that people have, when you walk into an engineering org of, a few hundred people, there's always like 30, 40 vendors that they're talking to in various capacities. And so all those become like different integrations that you couldn't integrate with. So, yeah.
Hey, I'm kind of curious, what part of the mental model breaks for someone who has been used to like deploying things with containers? So I'm a developer. So I had to like shift working with containers. I had to like rethink the way that I developed apps a little bit and get used to new things. What would break if I switched over to a Unikernel? Yeah,
it's a good question. And, it is a common thing, which is why I wanted to show that demo, because a lot of people, probably one of the most common questions that we get is like, oh, where's the orchestrator for it? And our kind of stance is like, you don't need one. So you can use one, you can make your own if you want, but it's not something that we think most people need because the clouds are so good at what they do already. And, like Google talks about how their data centers are huge computers. We're just providing the operating system for it.
So like as an engineer, like we think in terms of problem and tool to use for problem, and from your presentation, what I saw is like, okay, we have this company which is using nanokernel, we have that company which is using nanokernel, but what is the best use case for nanokernel? Like what is the problem? Like, hey, if you have problem A, use for sure nanokernel. Do you have something like this?
Yeah, so the bread and butter software that our users are doing is just most of the software that you guys are using, all the web app software in the world. We don't do interactive software. So if you're trying to do some sort of, just typing random commands into the shell, that's not really something that we do. But if it's like a server application that you're deploying out to prod, that's a good fit. Yeah, so it's likewise, it's never going to be the year of the desktop, nano system. We don't do any sort of desktop or anything. It's strictly for kind of server workloads. So.
Okay, one more.
Does it become more difficult to right size your compute when you're not running inside of a Kubernetes environment? You just have raw VMs.
So in terms of auto scaling, you can use auto scaling groups and so forth. We we've got users that do both Google's and Amazon's version of that, and they like that. I think for a lot of users, though, it's really kind of comes back to your workloads. Do you need something with 5 threads, or do you need like 64 gigs of RAM? Or I think most engineers have a good feeling of like what their workloads need. And so if you don't know, then I would say just use the auto scaling groups. So